All right. Hello, everybody. Welcome to our eighth AI fireside chat for this Vercel AI Accelerator. We have Zeke from Replicate here today to talk to us about the explosion of AI and open source and essentially how to leverage all of these open source models with just a few lines of code. Zeke is a developer advocate for Replicate. They've been doing a lot of great stuff. They're an official partner of the Accelerator as well. You all should have received your, I think, $5,000, a very generous $5,000 worth of credits each. Without further ado, thanks for being here, Zeke, and take it away.
Cool. Thanks so much, Hassan. Hi, everyone. Got a nice, modest group here. That's good. Not too scary. Let me see if I can share my screen. Can you all see my screen there? A GitHub issue?
Yep.
Okay, cool. All right. So I didn't really prepare a formal talk. And since we have a nice small group here, I just want to let everyone know that you should feel free to jump in at any time if you have questions or comments, and we can keep this kind of free form. So if you want to follow along with some of the stuff that I'm talking about here, I will drop a link in the chat to this public GitHub issue, which has a few links to stuff, but it's definitely pretty rough around the edges. So I guess I would start by introducing myself and talking a little bit about how I ended up at Replicate and what Replicate is and how I see it fitting into the picture of software development today. So about 10 years ago, I worked for a company called WordNick, and WordNick was a venture capital funded startup in the Bay Area that was trying to build the world's largest English dictionary and build APIs around it that could be used by software developers, educators, etc. And in the process of creating WordNick, we had two different teams, one team that was building an API and one team that was building a web front end. And they had very different cultural values and approaches to building software. So one team used Java and MongoDB and they built the API, and the other team used Ruby on Rails. And we saw that it was hard to see eye to eye. It was hard to agree on how to develop software when people had such sort of differing views on how to write computer programs. So if you've not heard of Swagger, it's an open source tool for describing web APIs. It's now called OpenAPI. And effectively what that was a contract between two teams to describe the function of an API in a sort of language agnostic way. So you write a YAML file that says, here's the function of my web service. Here are all the operations that can perform. Here are all the parameters. And around this, people can build tooling, people can build tests, and all this kind of interesting stuff where everyone agrees about the functionality of the application because they have sort of a shared source of truth. So there's a reason that I'm bringing this up because it sort of ties into the sort of design thinking around how Replicate works. So my last 10 years in tech have been mostly building open source developer tools. And Heroku was sort of like the start of that for me after I worked at WordNick. And Heroku, which I'm assuming most of you all know, but Heroku was a platform that kind of revolutionized the way that people could create and deploy web applications in a scalable way. And what was so cool to me about Heroku was that I was just kind of like a regular old web designer. I knew how to make websites, but the process of sort of standing up a web server and configuring a database and a load balancer and doing DNS configuration and all these sorts of things was really pretty difficult. And Heroku made kind of a standardized way of being able to do all of that stuff. So all of a sudden, the person who was just a web designer was suddenly capable of doing way more as an individual. And that was so appealing to me that I ultimately decided to go work there and sort of advance the cause of that. And the sort of last 10 years of what I've been working on have all been related to that. So after Heroku, I went to work for NPM, and NPM was like this really simple, small piece of software that allowed people to add functionality to their web applications in this really easy way. So instead of having to reinvent the wheel and write your own code, you could just search for something on NPM install it, and be off to the races with all these new capabilities in your applications. I won't belabor the long arc of my career to that point, but what I'm getting at here is that like I love developer tools. I love being able to work on things that make mere mortals able to do really powerful and amazing things with computers. So the 12-factor app methodology, if you haven't heard of it, is something that was written probably 12 years ago. It's pretty old now, but it is a really sort of essential and still highly relevant kind of doctrine about how to build web applications in a way that actually scales and aligns with the way that cloud applications work today. So the reason I bring this up is because Replicate is a team of software engineers who come from this sort of school of 12-factor app methodology and have this common goal of trying to bring really powerful technology into the hands of people who don't necessarily have tons of expertise or background in it. So I threw them this hot take here. Vercel, I think of as being the spiritual successor to Heroku. So Vercel today is obviously the sort of default choice for when you're building a web application and you want to go from like it's running on my machine to it's running in the cloud, it's scaling instantaneously to serve users around the world, it's running on the edge. Vercel has sort of taken everything to that next level, and I just want to give a shout out to Vercel because you all really know how to like set the standard that we can all sort of follow for how development should be done and how it should feel. It should feel fast and it should feel empowering. So I want to talk a little bit about the Replicate team and just who the people behind what we're doing. So I know all of you in this group here are, working on interesting new projects. And I just kind of want to remind you that if you're working on something involving Replicate, of course, there are humans on the other side of that interaction. There are humans who are behind the tools that you're using, and there are a lot of experts here. So, for example, let's see, Pontus. Pontus is our one and only support engineer. So if you ever send an email to team@replicate.com or something like that, this is probably the person who's fielding your query, bringing it back to our team. And sorry, I thought maybe, Ben, you had your hand up, but no, you're just yawning. No worries. So yeah, this is a really incredible team. I just feel really fortunate to be working with these people and doing some cool stuff. So enough backstory. Let's jump in. Let's talk a little bit about what Replicate is and what it's for. So I think of Replicate as being kind of like Vercel, but instead of for building web apps, it's for running machine learning models. Let me check hey, Hassan, why don't you, if anybody's chatting or asking questions, can you jump in and interrupt so I don't have to pay attention to that?
Absolutely.
Cool. All right, amazing. So Replicate is a platform for running machine learning models, and you can run public models or you can run your own private models. So an example of a public model is something like, let's do Stability AI's. Oh, no, sorry. If you all haven't seen it, you've probably all heard of Stable Diffusion. There's a new version of Stable Diffusion that came out last week that was open sourced. It's called SDXL. It's just kind of the next generation of Stable Diffusion. And when you come to replicate.com, you'll see there's Wow, it looks like we, as of recently, have like a full width layout, which is pretty cool. I didn't even know that shipped. So when you come to this site and you're looking at these models, this is an example of a public model. So you don't own this model, but you can run it. And we have two different ways to interact with these models. So you can come to the website, you can fill out a form. I can say, a person giving a talk on Zoom, and this is, who knows what's going to come up here, but this is the web interface gives you a really nice way to just sort of play around with the model, see what the inputs and outputs are, and get a sense of how it works. Hey, there's somebody giving a presentation on Zoom. But the cool thing is every single one of these models also has, I see, Eric, your hand is raised.
Hey, I was just noticing in the output there, it was downloading the model into the container. I would love to hear a little bit, just as you go through, if you can, about how you're dealing with cold starts and downloads and container size. I mean, like the models can get very big, and that's a big part of your infrastructure. And yeah, so just as a queue up for maybe later if you have time, I'd love to hear about that. I mean, yeah, even models get big there. I mean, so there's a question of in Replicate, is it better to download them and keep them as a part of your container image, or is it better to download them on the fly? Like what sort of networking? Like that's a whole discussion about optimization and running in Replicate the platform.
That's a great question. Let's come back to that one. And that's a very timely question indeed. So what I was saying here was that every model has its own API. So when you're looking at a model, you click on the API tab and you can see some example code for running that model with a bunch of different programming languages. So we kind of default to Node.js. That's everyone's favorite. Of course, Vercel's favorite as well. And from on this model page, you can see all of the inputs that are expected for that model. So on the Explore page for Replicate, you can kind of get a sense of some of the more popular models that are coming out right now. Of course, Stable Diffusion is really popular, and then there's this whole proliferation of Llama models, which I'll talk about in a little bit. So one thing that may not be immediately obvious, though, is that you can also run your own private models. So if I go to my Zeke dashboard, and I go to models, maybe I have some, do I have any private models? Here's one. Okay, so a private model is a model that, just like a GitHub private repository, it's a model that only you can see and a model that only you can run. So if you have a business case for building a model and you have maybe private data or some private functionality that you don't want to share, you can use Replicate for that. And of course, the pricing for that is the exact same as the pricing for running predictions on public models. So with Replicate, you pay per second for the prediction time that you run, and it varies depending on the type of hardware that the model is running on. So like I said, every model has an API. We've got client libraries for a bunch of different programming languages. So of course, Node and Python are probably the most prominent and relevant in this group, but we also actually maintain official clients for Swift, Elixir, and Go as well. And we have a bunch of community contributed clients. So one thing I wanted to touch on, which is important if you're doing predictions at scale, is that there are different ways to sort of consume a prediction coming back from a model. So we support webhooks. And what that means is when you create a prediction using Replicate, you can specify an HTTP URL and say, it's basically saying, hey, give me a call back when this prediction is done. And that way you can kind of like ask for your prediction, hang up the phone, and then know that we're going to ping you at the URL that you specified when the prediction is done. So this is really useful, for example, if you are building an app and you want to be able to save the outputs of a prediction. You could have a webhook handler that will say, oh, okay, your prediction's done. You generated a nice image with Stable Diffusion. Now I'm going to stick it in the database. So webhooks are not essential, but they're a really important thing to know about as you start to build a web application with Replicate. We also are just barely rolling out this streaming capability. So you probably all use ChatGPT, and maybe I'm not logged in. But as you type a query to ChatGPT, you always see this kind of like, you see it typing out the response. And at first you might just think like, oh, they made it look like it was typing. Yeah, Hassan, you got your hand up.
Yeah. Streaming is very cool. I just wanted to touch on webhooks that you mentioned. Another cool thing about webhooks is that you don't, especially if you're doing stuff server in serverless land, you don't have to have your serverless function executing the whole time. If it takes 30 seconds, you don't have to have it running for 30 seconds using up that compute. You can just have it run and then just close, and it'll, Replicate will run the prediction in the background and will hit the right webhook for you. So that's super convenient. And then there's a bunch of love in the chat for Replicate. Looks like a few folks are using it.
Okay, cool. Oh, first timers. Awesome to hear. Okay, cool. Oh yeah, and the animate model. I actually haven't even used the animate model yet, but my colleagues are getting a kick out of it. Yeah, so like Hassan said, webhooks are a nice alternative to the default sort of method of creating a prediction and then repeatedly polling for it. Because if you're in the context of a Vercel app and you're polling for a response, you're sort of needlessly using up a bunch of runtime that's going to cost you. So you might as well ask for a webhook, hang up, and receive it to sort of minimize the amount of compute time that you're using. And if you want to see an example of that, if you go to the webhooks guide and scroll to the bottom, we have this web app called Scribble Diffusion, which if you haven't seen it, it's kind of fun. And it's an open source app. So of course we have a live working implementation of webhooks that's pretty easy to copy and get running with. Do you use webhooks in Room GPT as well, Hassan?
No, I actually don't, but maybe I should switch. Yeah. It's just that it's fast enough that I'm just like, I don't need to. Predictions take 6 seconds-ish on average. So I'm just like, I probably don't need it. But I know my coworker, Steven, uses it for a couple of his sites. One where he's using the aging model. I don't remember what he used for that, but I remember it took 45 seconds or something like that. So he implemented webhooks.
I'm using webhooks. So it works great.
Oh, you are as well, Eric. That's awesome.
Yeah, I am. I'm using it pretty heavily. Definitely you need to make sure to create your own signing secret though. So be careful there, because I definitely get bot traffic.
Just gonna take a little note here. Don't mind me.
I actually don't think you support signing secrets, but you can do your own shared secret.
Yeah, basically, the idea is when you specify your webhook URL, you put a query parameter or a token onto the end of the URL to say, I better check this when I get the URL back to make sure I got what I was expecting. So I think this is the app that you were talking about, Hassan, that your colleague Steven built, which again is open source. And I bet if we do a little webhook search, sure enough, it's using webhooks. And you can filter webhooks, so you can actually not only get the completed state of a prediction, but you can get a webhook every single time new logs are emitted for the prediction. So it's pretty useful. And then similarly, then this is very, very new, as of last week, we now support streaming. So what I was mentioning here is that when you're using ChatGPT and it's doing this fancy animated typing thing, that's not just an effect to make it seem as though you're talking to a bot that's typing. That's actually the way that these models produce output. They are sort of iteratively looking for the next token and spitting out words as they go along. And the web service, OpenAI, is using a streaming API with server sent events to just publish those updates as they come in. So similarly, Replicate is rolling out this kind of capability for ultimately for all language models, but we're starting with the new Llama models that have come out in the last week or so. And if you want an example of this, did I link to it here? No. We have the, like all good AI companies, we have the obligatory open source chat application. Everybody's got one. But this is, again, some working code that you can use to sort of get an idea of how to use streaming in your application. This is also, like I mentioned, this is very new. So if anybody tries this and has feedback on it, definitely send it our way. I want to be conscious of time. I have like a few more things that I wanted to cover. How are we doing on time, Hassan?
No, we're good. We're great. If anybody has any questions in the meantime, please, raise your hand or put it in the chat. We can address it.
Okay, cool. Eric, I see you raising a finger. No, okay, cool. I don't know if we're gonna have time to get into all this stuff, but I want to show you a few cool things that have been happening in the last week or so. This one's not super new, but it's really cool and useful. So we built this app called Zoo, which is kind of an open source playground for comparing a bunch of image generation models simultaneously. So if you want to know, how does Stable Diffusion XL compare to Stable Diffusion 2.1, you can use this app to do that. Also, if you have your own model and you want to, let's say you're producing your own image generation model and you want to compare it side by side to some other model, it's really easy to actually clone this repository, run it locally, and then connect it to your own model and be able to see the outputs side by side. So I think we have, let's see, YouTube, what is it? Replicate. We have a handful of video models on our YouTube channel, and yeah, there's a video there about ads. There's a video there about running your own copy of Zoo for generative image models. It's really fun to play with Zoo, and it's become kind of like an indispensable part of my just image generation workflow. Also, it's free. Like you're not paying for the iterations that you run on Zoo, the predictions that you run on Zoo. We're just kind of footing the bill for that. I'm going to skip some of these, but they're definitely worth checking out. I think the most timely one is LLM Boxing. My colleague Charlie made this website that pits Llama 2 against GPT 3.5 and anonymizes the results and lets you pick which response to a language model you can to a query, which language model has the better result, and sort of it's like a blind test. And what we've seen so far is that Llama is ahead of ChatGPT, at least 3.5 in terms of its this is just the base model or the chat model, the 70 billion parameter model, which is pretty impressive. This wasn't really a week and a half ago, there was no open source language model that was even close to the GPT 3.5 in terms of its performance. So this has been a huge week for Replicate. Lots of really exciting stuff coming out in terms of language models, and just a ton of energy around that.
Can you talk to us about the price difference, by the way? What is the price difference between them, between running Llama 2 and 3.5?
Good question. I haven't done that analysis.
Okay.
We're actually about to don't anybody say this out loud publicly, but we are about to roll out an entirely new pricing scheme. So which will work in all of your favors. Let me just put it that way. In terms of apples to apples comparison, I think GPT-3 or OpenAI's language models are priced by token. And Replicate is priced by seconds, so it's actually kind of hard to do just like a back of the napkin comparison.
Fair enough.
But that, yeah, definitely an interesting thing to check out. I guess quickly I will touch on pushing models. So if you, obviously there's a bunch of models in Replicate that have all kinds of interesting capabilities, but sometimes you actually want to run your own model, especially now that we're starting to see it be possible to actually train these language models with your own data. So there's this tool called Cog, which is an open source tool maintained by Replicate. And this is that open API thing that I was talking about earlier kind of connects here. So Cog exists to sort of abstract away all the pain of developing machine learning models. So it takes care of, if you've ever worked on building a machine learning model, you know that there's this thing called CUDA, which is sort of like the device driver library for NVIDIA GPUs, and the sort of dependency matrix of figuring out which versions work with different versions of Python and for which GPU is a little bit, and for which version of PyTorch, TensorFlow, and all those things. It's pretty complicated. So Cog just sort of takes care of that. And what it allows you to do is define sort of a simple Python interface for your model. So you just define this predict method and you describe the inputs to your model. And this is the thing that ultimately becomes the kind of wrapper around your model and creates a standardized API for it. So when you're back at, when you're back on the Replicate website and you're looking at one of the models and you see this API, these inputs are actually derived from the Python interface that is wrapping the model. And Hassan, I know I was going to be talking about the proliferation of open source here, and this is sort of where, like, you know, I don't think we have a ton of time to talk about this, but when you look at the sort of, actually, I haven't looked at the source for SDXL. No, that's not going to be it. But if we look at the source code for the Stable Diffusion model that's on Replicate, it's like, you know, 140 lines of code. And part of why that's happened is because there's this thing called diffusers, which is popularized by Hugging Face, which is a Python package that packages the weights for tons of different machine learning models. So if you want to create like a derivative version of Stable Diffusion and wrap it in a Cog model and publish it to Replicate, you can actually do that with like 50 lines of code. And that's not a thing that was possible even just like 1 year ago. And so what's really exciting is like, I mentioned earlier how we had the rise of NPM, and all of a sudden it became the barrier to entry to like publishing a piece of software became really, really low, and people could just push stuff into this registry and anyone else could just like NPM install it. I feel like we are in that state now, or at least sort of like at the beginning of that state with Hugging Face, and people putting all of these weights in Hugging Face as the sort of artifact registry for these packages like diffusers and transformers. And that's a whole long topic to get into, but I think I want to pump my brakes here to make sure that we have time to dig into some of the stuff that y'all are interested in covering. So let's switch back to, I'm going to take a look at the chat here.
Yeah, thank you so much, Zeke. That was awesome.
Yeah, sorry if it was a little rambling. Hopefully it was useful.
No, that was great. And just to clarify that last part that you're talking about, that's really just for pushing your own models to Replicate, right? You don't need to, none of that is like, you know, information that you need to know in order to use Replicate. Yeah. You just need these models.
Yeah, if you're just running your own models, I mean, if you're running models off the shelf that are already on Replicate, like all of these different image generation models, like let's take a look at, you know, if you go to replicate.com and you click explore, we have these collections, which are, you know, collections of models that perform different tasks. So a kind of classic example is a lot of times when you're generating an image with something like Stable Diffusion, the output is maybe 512 by 512 and you want something bigger. So you can use one of these super resolution models to take your smaller input and produce a bigger version of it. And yeah, all you got to do is just take this little tiny bit of code, like literally this, drop it into your web application, and you're off to the races. You never have to know anything about Hugging Face. You don't have to know anything about GitHub even. You don't have to, I mean, you do need to sign up for Replicate and put a token in your environment, but once you're doing that, like, you're good to go. So the sort of base use case requires zero machine learning knowledge to get started. But right. we are very focused on giving people the right tools to be able to build their own models and deploy them using the same exact tooling and the same infrastructure that you see for public models.
I love that.
So jumping back to the chat, do we have any questions here?
It doesn't look like it yet. If anybody does have any questions, like you said, drop them in the chat or use the raise hand feature. We'll officially kick off Q&A. I think we had that one from Eric from before that you put in your GitHub note. And sure. Yeah, this is Wonders, which is one of the startups that, or the startup that Robin is working on for Accelerator.
Cool. Thanks for sharing that. Super nice. We use Replicate to create an image for every research paper that comes up in search results, and it's so cool. Like, it is gorgeous. It feels like a little story, you know. And yeah, I just appreciate all of your work. So thank you.
Amazing. Thanks for that. It's good to hear. I want to bounce back to Eric's question about models getting big. So how do we deal with cold starts? Do we download models on the fly or keep them running in a container? Wow, you really asked like $1 million question right there. No, I'm not sure I have a short answer to this one. So Replicate has gone from 4 people to something like 25 people in the last year. And cold starts is our biggest technical challenge by far. It was actually really validating when I went to a recent Vercel event to hear them talk about how hard that is. Like, even when you're just like running, even when you're packaging and deploying JavaScript apps, which compared to machine learning models are very small. The process of trying to make, a machine learning model, which is, 20 gigs. Oh, I think my camera might have died there. Can you all still see me?
Yeah, I think you're frozen.
Let's see. Okay, you're going to see the Wizard of Oz view now. This is the real me with the green screen. There's no short answer to your question, but one of the things that we're really trying to work on is figuring out how to just cut down the time to boot. And that involves things like taking a memory snapshot, like an in-memory snapshot of a running model, and then saving that in storage so that when we pull a model off the shelf, it never even actually goes to disk. It just comes straight off the network and streams right into RAM or GPU RAM. And there's just a bunch of different optimizations in that process to make the model faster. For popular public models, it's not an issue because there's so much ongoing consistent traffic that they just stay warm. But if you have a model which is not actively receiving a lot of traffic, then the model gets idled and there's a long delay to bring it back to a running state. And I'm reluctant to throw out any numbers, but we've seen like dramatic performance improvements in this effort since, just in the last few weeks. And so the team is not necessarily, I don't think we're in a position yet to be able to publicly make any kind of statement about that, but I can say that that's like top priority in terms of our models team and our infrastructure team in terms of making that fast. So I will say that I can connect you if this is sort of thing that you are wondering about in developing your own models. Hopping into the Discord that the Vercel team set up and asking that question, I can make sure that the right people on the Replicate team can jump in there to give you more context.
Thank you. Yeah, I thankfully at the moment I'm working with a lot of async stuff, but I'm noticing my model sizes are getting large. I'm chaining together several models at a time, and things are I'm watching that time creep up and wondering if I'm shooting myself in the foot with the sometimes the optimizations you think you're doing are deops. Curious. That's the impetus for the question.
Yeah, we actually have a new feature that we're rolling out, and if it would be appropriate for you, I can get you added to it. But it's called deployments, and when you create a deployment, it's giving you a customizable instance of a model that you can change. You can change the number of running instances for that model with a set minimum or max. So it's kind of like if you want to keep your model hot at all times, you have some flexibility over that. So that's something that actually anyone in this group, if that's something that appeals to you or that you might need for something you're building, definitely get in touch. I will add also that my email address is just zeke@replicate.com. So if you're like, I'm posting messages in the Discord and Zeke's not answering, send me an email. I'm also Zeke on Twitter. And Zeke
so
on
jealous
GitHub.
of that name. I can't believe you got @Zeke on Twitter. That's insane.
Yeah, I remember I was working for this company in Santa Barbara in like 2007, and I was sort of my first time really getting my feet wet learning Unix, and Amazon Web Services had just come out, and I was working with these like hotshot web developers, and they were like, there's this thing called Twitter, and I was like, I don't even understand what this is. It was like an app where you could send a text message to the number 40404, and it would like spam everybody that you followed with text messages. So in the beginning, there wasn't even an app. It was just like this like text message spamming service. But yeah, luckily got the name early on. Do folks have other questions?
Nice. Any more questions? I saw Eric had another one in chat, which I was actually wondering about too. If there's anything in the pipeline about chaining model runs.
Yeah, and for clarity on that, you were talking about NPM and the idea of like models as packages, right? So, when now all of a sudden your code is glue. So that's kind of what I meant there, right? Because of course you can make like an API call, but then now you have to set up a receiving webhook, and or you can run it sync, right? So, but the idea that you're working with like sort of a distributed asynchronous deal, and I'm sure Swix would sort of post about temporal, but because that's sort of their whole jam. But
yeah. Totally, yeah. So what comes to mind when you we definitely could use some documentation. But one sort of useful example of this in the wild is another app created by the LLM boxing person, Charlie, who's just really fun. Is this thing called Teach-O-Matic, which I think I've got a link to it here. Teach-O-Matic.net. So it is a sort of proof of concept website that makes really silly instructional videos where you give it a prompt and it uses a bunch of different models. It uses OpenAI to generate a script or like a narrative for the video, and then it uses a model on Replicate called Bark to generate sound effects, and then it uses a different model to generate audio for the background, and then it uses a different model to generate narrated, like a speech narration for the video, and then it uses another model to generate video segments that correspond to what's happening at that part of the instructional video. It's kind of bananas, but it all uses LangChain, which you've probably all heard of. LangChain gives you a way to kind of like you said, to sort of glue all these different models together and then be able to sort of sustainably write some code that you can actually follow instead of inventing your own system or sort of like piping output from one model into another. So this notebook is a sort of good reference point for, hey, I want to make a thing that uses like some image models and some text models and does a bunch of stuff and then cooks it all together into one thing at the end. So definitely check out this notebook if you haven't already.
Is that just awaiting results, or is that I guess how is it composing them given just the Replicate API that you were talking about earlier?
Yeah, it's doing this thing called a sequential chain. So some of it is like, in some cases, some of the inputs depend on previous outputs before they can run, whereas others can be run in parallel. So I don't know exactly where this code is, but for example, let's say you have the prompt for generating 3 videos, and you already have those 3 prompts. So you can use LangChain to say, hey, Replicate, generate 3 of these videos for me independently and come back when you're done, and I'll take those videos and then use them all as one input to another thing, which will chain the videos together into one sequence. So I know I'm dodging your question a little bit. It's like, there's not like a totally straight answer, but it's a combination of doing some things in serial and some things in parallel, depending on whether or not you need to wait for the output of a different operation.
I guess maybe a better question is like, this Python code is not running in a Replicate model, or is it? Like, is this?
It
is
is
this
not. No. So this code is running in a Jupyter notebook on a hosted Colab instance. But what you're touching on is actually a really interesting question, because a Replicate model doesn't actually have to be a machine learning model. It's just some code that takes input and receives output. So theoretically, you could actually take the entire contents of this notebook and put it into your own Replicate model. And it's one of those things where we come up against this a lot, where it's like, do we make a Vercel app and like focus a lot of the energy in building capabilities into the web application? Or do we make a machine learning model that wraps it? So what would be a good example of that? Okay, so we have this app called OutPainter. So OutPainter is a thing that uses stable diffusion, where you provide a source image and then you provide, Fox, you provide a prompt and it sort of fills in the outer area. Okay, that's kind of terrible, but let's try it again. But you get the idea. There's an input image. You could imagine that, okay, I gave it too hard of a prompt. Okay, that's kind of interesting. You could imagine that if we go back to this, the input image to this model, to the stable diffusion model, needs to be, it needs to take a couple different inputs. So let's look at Hopefully I can explain this in a way that actually makes sense. So the in-painting model.
I know we're a little over time, so just a heads up let's try to wrap up in a couple minutes.
Okay, cool. Yeah, this might be a little too long-winded, but the idea is you might want to make a web application that takes care of creating this mask for you. Like you could do this on Vercel using something like, there's like an NPM library called Sharp that generates images or that resizes images, or you could do it in Python. But then this question arises: should that be the responsibility of the web application, or should that be baked into a model that has sort of an inherent capability to say, oh, you gave me an image, I'm going to draw a big buffer around it and turn it into a mask? And those are some really interesting questions that are still being explored. I think we have, there's a person on our team who, if you're into visual stuff, you should definitely follow Paul. Paul created, here's an example of this is not a machine learning model. It's a model that takes a video file as input and turns it into a bunch of frames. It gives you back the frames. And there's another one that does the opposite. So you're it's up to your interpretation of how you want to make a model on Replicate that takes input and output. Let's leave it at that. So we're over time. I hope this was useful for you all. I'm readily available to talk to any and all of you, and I'm hoping to maybe meet some of you. Are we doing a Vercel in-person San Francisco thing at some point, right?
I don't know if we're doing another one. We did one, I think.
Okay.
I'm not sure.
Oh, I missed it. I was out of town. That's right. Okay, thanks.
We're out of town. Yes.
Okay.
Cool. Well, thank you so much. This was great. Appreciate you coming and doing this talk.
Yeah, thanks for the questions, y'all. And I'll see you on the internet.